So welcome to Stat 200 Lesson 2. In this lesson, we're going to be covering a lot of material, so we're going to try and go through it kind of fast. I put a little bit more of an emphasis on combinations, since a lot of people seem to be asking questions about that. So once we get through all this, I have a ton of questions at the end that we can all go through. So first off, a little bit of review, types of variables. We have the categorical with the subsections of nominal, which, they have no meaningful order. So example of that is just color. You can say red, blue, black, and you can't really put them in any order that would make sense or, be different. Like everyone would have a different order which they would put red, black, blue, just because their colors doesn't really matter. Then you have ordinal, so it's variables that do have a meaningful order or kind of like ranking. So for instance, there's freshman, sophomore, junior, senior. Just kind of goes in that order. That's the way it is. It's kind of like the increase of rank. Next up, we have quantitative variables, which are the numerical ones with the subset of discrete. So that's data that can only really take on like specific numbers. So, it's how many hours did someone do something? Well, you can only really say 5, 6, 7. You can't really break it down much more than that. Or continuous, where it can be like continuously broken down. So an example of that is kind of weight, because you can take it from the pounds down to the ounces, down to, however many decimal points that you want to go for trying to rank weight. So then now we're going to be moving into more of how you can like kind of represent the data. So for one categorical variable data, you'd always use a proportion, which is just number in the category over the total number. You use p hat. I'm sure all of you have already had this like drilled into you, and it always has to be a number between 0 and 1. If it's anything more than that, then something's drastically wrong. So here we're going to be talking about the shapes of graphs. So a lot of times the shape of a graph is, how you can kind of like just visualize how data is recorded. So usually the distributions are going to be either symmetrical, as the one down here, or skewed, as the ones up in the top. So symmetrical data, basically the graph has it set, one side is pretty much the exact same as the other side, or, it's just very similar. As you can see here, this is a normal distribution, so it has a mean centered at 1 and standard deviation of 1. And then skewed, basically it's just more data is on one side of the graph. So as you can see here, this is a right skewed, as the tail skews off to the right, and just more data is way over here on the left side. And then we also have the central tendency. So the mean is just some more vocab. The mean is the numerical average. The median is the middle of the distribution, and it's going to be ordered from smallest to largest, and the most frequently occurring value. So in a symmetrical graph, they would all be the same. They'd all be right at the middle. And so a very important thing to note is an outlier is an observation that is just not with the other observations in a distribution. So as you can see in this one, the outlier is just very far away from the rest of the graphical data. So it would mess off your results for any kinds of study or anything. So it's something that you have to be very aware of. All right, so as I kind of hinted at earlier, if something is skewed, then it'll have an effect on the mean, the median, the mode. And this is something that you can figure out by looking at a graph, or if you want, you can just try and memorize it. So basically, if it's symmetrical, the mean is going to equal the median, and it's going to equal the mode. That's just how it's going to be. However, if it's left skewed, then the mean is going to be smaller than the median, which is going to be smaller than the mode, as you're going to have all those high numbers over to the right side, but they don't occur very frequently. I'm sorry, that's for left skewed, you're going to have all those numbers on the left side that don't occur very frequently, but they just kind of mess all your data up. And then for right skewed, you're going to have the mean, which is larger than the median, which is larger than the mode, because you're going to have those numbers over on the right side that really just go and mess everything up. So another thing that you definitely want to remember is the empirical rule, So for any bell-shaped distributions, 68% of the data is going to be within one standard deviation, as you can see here. 95% is going to be within two standard deviations of the mean, and 99.7% is going to be within three standard deviations of the mean. So you're going to probably get some questions where it can either ask about like the standard deviations, or given that it's falls between like 99.7%, how many deviations, stuff like that. You just have to figure it out. All right, so talking about displaying variables, so you have a few different ways. So one of them is a frequency table, which you see all the time in Minitab. It's basically a table that contains the counts of how often each category occurs. And you also have a pie chart, which is a representation of it with a circle that is just sliced to show the proportions of each category out of 100. And then you've also got one more, which is the bar graph. It's it uses bars. It's usually going to see it as vertical. Sometimes you'll see it as horizontal. And so those are the three real ways of representing categorical data if you have one variable. That's very important to remember, that you only can use it with one variable. And so for two categorical variables, it's normally going to be a two-way table. So as you can see here, you've got one variable on the top and one variable on the bottom, and it just looks very much like a frequency table, but just records every other count. And okay, moving on to probability. So the probability is just the probability that something's going to happen. It's very much like proportion, ranges decimals, but can be changed percentages if you'd like. Ranges from 0 to 1. And if you have 1, that means that whatever you are predicting is certain to happen. And with that, if you have a 0, that means that whatever is going to happen is impossible. So here's the stuff that everyone's been asking me about: combination of events. So with intersection, it's the probability of A and B. With union, it's the probability of A or B. So I want you to imagine a Venn diagram. So intersection is the Venn diagram bits where there is no middle ground. Union is, intersection is that little middle ground. Union is where there is none of that middle ground. And if you're going to look at complement, it's the probability of not A. So just imagine a circle in a box, and that circle is A, and everything else is just not A. And then conditional is the probability of A given B. This one doesn't really fit into that Venn diagram category, but basically it's saying that how likely is A going to happen if B is present. So I'm going to dive a lot more deeply into this so that you guys can understand a little more. So for complement, it's as simple as number in the group over the total number. So an example of this is if there's a six-sided die, the complement of an even number, so there's going to be 3 even numbers in the group over 6 total numbers, and so the complement of that would be 0.5. That one's a little bit more of an easy one. So they do get a little bit trickier as we go on. So intersection. So you basically want just, you want to find exactly what it's asking for. So it's asking you for both people who are female, so you're looking for this category, and people who prefer cats over dogs. So you just have to follow that through, and you find that it is 43 in this table that I just randomly created, and then you have to divide that by the total, which is 200. And so you would eventually get it to be 0.225, or 22.5% are female who prefer cats. And so just an important thing to note, if that number is ever 0, then the events are disjoint and they never occur together. So basically, they're mutually exclusive. There's no way that it would ever happen, or one would happen with the other. So an example of this is someone being a freshman and a sophomore at the same time. It just can't possibly occur together. So conditional is basically preferring something given something else. So, Oops, sorry. So union is one or the other. So I did a few examples of this because this is a little trickier to get your head wrapped around. So, for example, female or prefer cats. So you have to look at the entire female category, and you see that there are 100 total female, and preferring cats, you see that there are 70 total people who prefer cats. So then you take those numbers and you add them together. However, what you also have to do is subtract the intersection group, because there are going to be females who prefer cats over dogs. And so if you didn't subtract them, then you'd basically be counting them twice. So then you have to subtract the value of the intersection and then divide by the total to get your value, which in this case is 0.625. And so then male and preferring dogs. So again, there are 100 people who are male, 130 who prefer dogs, and then you have to subtract the amount of males who prefer dogs and then divide by the total, and you end up getting 0.8. So here's conditional. So it's they prefer something given something else. So you have to be very careful of the wording in this situation, because as you can see in my example, if you just change up the wording a little bit, it gets you two drastically different answers. So if they prefer dogs, given that they are male, so you're only really interested in the male category and interested in how many prefer dogs. So that's 75 out of a total of 100. And you just don't have to worry about the female or the total categories. But if it's male, given they prefer dogs, then you have to look at the dogs category over here and see how many are male. And so you still get the same 75, but this time instead of out of the total of 100, you get a total of 130, which shifts your answer from being 0.75 to 0.557. So just, something to spring off that, independent events, it means that A and B are completely unrelated. Or, so it happens when the probability of A is the same as going back. If it's conditional, probability of A given B. So it's saying that basically it's just saying that exact same thing. B does not have any effect on A. So I don't know. An example of this could be like test scores and weather outside. They might have something in common, but in most cases, it probably has no effect unless, well, again, there's probably so many lurking variables there, confounding variables, that I can't say that, but just as an example, has no effect on each other. All right, so now that we've kind of passed from the categorical stuff, now we're going into more quantitative stuff. So how you really display quantitative data is using dot plots and histograms. So they're similar to bar graphs, but instead of using a bar graph, it's called a dot plot and a histogram. So for dot plots, you just count the number of dots, and histogram is the height of the bars, and that's how you kind of like visualize quantitative data with only one variable. All right, so moving on to some other fun stuff, we have risk and odds. So both of them are just questioning the likelihood of an event to occur. So the risk is the probability that event will occur. Same formula as proportions and probabilities. It's just the number of the outcomes over the total number of outcomes. But odds is the likelihood of an event happening versus it not happening. So an example of, it's basically the number with an outcome over the number without the outcome, or risk over 1 minus risk. I'd only ever use that formula if you already have the risk, or else you'd just be doing more work for yourself. But it's just something nice to have if you already calculate the risk. And then other fun stuff you gotta know, z-scores. So a z-score, what it's asking for is the distance between an individual score and the mean and standard deviations. You might also hear it as a standardized score. And so in the formula, it's z equals x minus x bar over s, where s is the standard deviation, x is the value that you're given, and x bar is the mean value. And percentiles, just, So if you gotta know, it's the proportion of distribution less than a given value. So for an example, test scores. We all had to take the SAT. I picked this particular one because I had a teacher up here at Penn State who prided himself on getting into the 51st percentile because that meant he was better than average. And so if you score in the 51st percentile, that means that you scored better than 51% of students who took the test. Likewise, if you say scored in the 90th percentile, then you scored better than 90% of people who took the test. So just, keep that information in case you ever need to use it on an exam. All right, and here's something you're definitely going to get a few questions on, and that's 5-number summary. So in a 5-number summary, you're given, of course, 5 numbers. So the first one's got to be the minimum, followed by the first quartile, then the median, the third quartile, and then the maximum. And so the first quartile is going to be 25% or the 25th percentile, and the third quartile is going to be 75% or the 75th percentile. And so with this, you're really going to be asked, if you're ever asked to calculate anything, it's going to be one of these two questions where it's range, which is asking the difference between the maximum and the minimum, or IQR, which is asking the difference between Q3 and Q1. So we'll get a chance to practice this later on in the video. Oh, and here we go. All right, so we're already on to our first review question. So I'll give you a little bit of time to work on this, then you can just post your answer. All right, so I'll just go on and explain it. So because this graph is left skewed, as it is, the tail is way over here, and then the main graph really, it starts to pick up over here. And so it's left skewed. So that means the mean is pulled towards the left, so it's then the smallest. The median is in the middle of that. It's also going to be kind of pulled a little over. And then the mode is largest because you have all these more frequently occurring values up here. All right, so next question. Give you guys a little bit of time to work with that. All right, so I'll go over this. So z-score is x minus x bar over standard deviation. So since you have the mean of 500, that goes where the x bar is. Since you have a standard deviation of 100, that goes where the s is. And since it's asking you to find 600, that just goes where x is. And so you plug it all in, you get 600 minus 500 over 100, which then ends up being 100 over 100, which is 1. So one very important thing is you always have to remember to interpret this. because they're going to ask, is it above the mean or below the mean? Like, was this, no pun intended, but mean? And so since it's positive, it's a standard deviation above the mean. So a score of 600 is one standard deviation above the mean. All right, and on to the next question. I'll give you guys a little bit of time to work with this. All right, so just one thing you have to realize is that 99.7% is 3 standard deviations to the mean. So for this, it's going to be the mean plus or minus 3 times the standard deviation. So since the mean is 500, you're going to be using plus or minus 3 times 100, since that's what they said what the standard deviation was. And so you end up getting with the lowest part being 200 and the highest part being 800. All right, moving on to the next question. All right, I'll give you guys a little bit of time to work with this through. All right, so in this question, the IQR is going to be Q3 minus Q1, which in this case is 16 minus 3, and you end up getting 13. Simple as that. All right, taking a little bit more of a twist on it, give you guys some time to work on this. All right, so just go over it. You're going to be taking the maximum number, which in this case is 20, minus the minimum number, which in this case is 2. Just subtract those, and you end up with a range of 18. All right, so this should be a relatively straightforward one, but something you might see on the exam, so I'll just give you guys a little bit of time to work with this. All right, so 75th percentile, that's the same thing as asking what 3 is. So in this case, it's going to just be 16. All right, this is a little bit of a longer one, so I'll give you guys a little bit of time to get through it. All right, so I'm gonna go over for you guys. So in this case, the mean x bar, as you guys have probably had it all drilled into you, is just going to be the addition of these 5 numbers and then divided by the total amount of numbers, which is 5. So it's then going to be 41 divided by 5, or 8.2. The median, you have to first order it from smallest to largest, and this one was just made that way. So you just kind of like cross out the smallest, then you cross out the largest, then you cross out the next smallest, next largest, and you end up with the middle one, which in this case is 9. And the mode is the most frequently occurring, which is also going to be 9. All right, so give you guys a little bit of time to work on this. All right, so this histogram is going to be right skewed. As you can see over here, the tail is being pulled towards the right, which is, just making it right skewed. All right, next up, just which one of these is most likely to be an outlier based on the distribution over here. I'll give you guys a little bit of time for this. All right, so in this distribution, most likely being outlier is 1, just because as you can see over here, it's so far away from any other observed value all the way over here that it's just kind of painfully obvious that something's not right with that one. All right, so here is the next question. I'll give you guys a little bit of time to go through this one. All right, so basically to display this data, since you're being asked with 2 categorical variables of either do you own a dog, yes or no, or do you own a cat, is then going to have to be the two-way table because it's asking you with 2 categorical variables. Histogram and dot plot are both going to be quantitative, and pie chart would only be valid for 1 categorical variable. All right, so number 11, this should be a very quick one, so I'll just give you guys a little bit. All right, so simple proportion, you just gotta take number in the group, which is 45, number out of the group, 100, and yeah, you get 0.45. All right, next question, a little different. See what you guys come up with. All right, so going over this, odds are different than risk, of course, so it's just going to be the number with the trait over the number without the trait, which in this case, since it's men, it's 45 over 55 or 0.818 to 1. But since you already calculated the risk, if you wanted to, you could use the other formula to go through this, which is just risk over risk minus 1 or 1 minus risk, which would get you the exact same answer. So just, something to work with. All right, number 13. This one is gonna take a bit, so I'll give you guys a fair bit of time for it. All right, so if you guys are confused, no need to worry. I know this one was quite the doozy. It's just, one of the ones to finish off the night. So here, I'll go through it now. Hopefully we can clear up any questions. So the amount of males who prefer cats, you know, this one's pretty straightforward, just 25 over the total of 200, end up getting 0.125. Females or those who prefer dogs, so this is a union one. So you gotta take the total amount of females, which is 100, total amount of people who prefer dogs, which is 130, subtract it by the amount of females who prefer dogs, which is 55, and then just divide that by the total, which is 200, and you get 0.875. And then compute those who prefer dogs given they are female. So again, this is the one where you have to ignore the other categories. So you can ignore male and total since it's asking about the females. So it's just females who enjoy dogs out of 100. And so you end up getting 0.55 from that. All right. So this was the last question. So sorry, that one's wrong. The next review is going to be this Thursday at 9 p.m. If you have any questions, be sure to let me know. And it's been great.